Hey folks, we are going to look at calculating the tension of a string in a system where we have a block and then a weight and just a nightmarish question. So here we go. This is what we're looking at here in our little question. All right, so what we have is we have this 75 kilogram block on our surface. We have a 72 kilogram block on our pulley system. And so what we're going to add in is we're going to add in a couple features to this ramp to try and make this question as difficult as we possibly can. So we're going to make this angle, let's call it a 30-degree angle here. And then let's add a coefficient of friction of, let's say, 0.20. All right, so we got about everything that we can add into this question in terms of just like a nightmarish question. So before we look at kind of anything in the question, what we want to do is we want to try and label our free body diagram. So first of all, what we know is that the object wants to fall this direction. So that will be my applied force. And what we know is that the tension of this rope is going to pull this direction here. If you watch my last video, you'll know that our normal force, our Fn, is working in this direction. And you'll know that our Fg is typically this direction, but with these types of questions, we always draw a little triangle like this. And what we know is we know that this top angle here is always going to be the same as the bottom angle as well. Okay. So we've got our setup there in terms of this top block. Now, we also have the block on the right over here that we got to set up. So for this one, we're going to do this one in blue. For this one, the force of gravity here, force of gravity is acting down on it, and the force of tension is acting up on it. And there's a really interesting concept that I want you to understand with whenever we have tension forces. And that is, if you have the same rope, you have the same tension. So when we look at the force of tension in red and the force of tension in blue here, because it's the same rope attaching both of them, they will both have the exact same tension forces going on. Now, as with the previous question and as with every type of question in this kind of unit, what we want to eventually be able to do is plug it into our universal force equation. Sum of all forces is equal to mass times acceleration. Now, what we have to do first is we kind of have to figure out what direction this object is going to go. And what we're going to do is we're going to compare this force and this force. Those are the two forces that will ultimately determine whether or not this object is going to fall in this direction or whether it's going to fall in this direction. And ultimately, that's the first conclusion that we need to arrive at. So the first thing that we're going to do is we're going to solve for the applied force, F of A. The F of A lines up nicely with this. The only reason this block would ever want to fall is because of gravity. And we're trying to see if this mass of this block is heavy enough to pull it down the ramp and pull this block up, or we're trying to see if this block is so heavy that it's going to pull this down and also pull this entire object up as well. Okay? So our applied force, what we do here is we have a 30-degree angle. So what we need to do is Fg, and we need to go sine of 30 degrees. Fg is the hypotenuse of this red triangle that I should have labeled, but I don't. There's Fg. And Fa is the opposite angle to this 30-degree angle here. So what that'll look like in terms of a calculation is it'll look like mg sine of 30 degrees. So we're looking at our mass of 75 kilograms times 9.81 sine 30. Okay, so we have 75 times 9.81 sine of 30. And what we know is that that falling force is equal to 367.88 newtons. And like I said, what we're going to do is we're going to check to see if that can beat out the force of gravity happening from the block over on the right here. So the figuring out that force is really, really straightforward. All we need to do is we need to say and calculate Fg is equal to mass times the acceleration of gravity. So Fg is equal to 72 times 9.81. 72 times 9.81. And that gives us a massive force of 706 0.32 newtons. So what we know then is, based on looking at these two answers that we have at the bottom, is this applied force is still going to happen. It's still going to be 367.88, but this gravitational force is bigger. And so what we know then in terms of the direction that this thing falls is it's going to fall in this direction. It's going to fall in this direction. So what it means is that this bottom block here has a bigger influence on the end game of this entire ramp. Now, what you also may have noticed is that I gave this ramp a coefficient of friction, but I didn't write a force of friction down. And that's because it depends what direction this block is falling. If the block was falling down to the left, so if it was falling down the opposite of what our system actually is doing, I would have labeled the force of friction here. But because of our blue arrow at the top, because this object is going to go to the right, what we know is that the force of friction is also going to work in this direction, the same as the applied force. Okay? So now what we're at a point now where we can calculate the entirety of this calculation. So I'm going to slide to the right a little bit here. What we know is that we want to calculate the sum of all of the forces, and we want to have that be equal to the mass times the acceleration. And ultimately, the acceleration is the thing that we don't know. So here are all of the forces that we have acting. We have Fg. That is the biggest force that we're going to have. So that's what I'm going to put first. And we're going to basically list everything that's fighting against it. So what we would do is we would subtract the force of tension. Now, what we're also going to do, though, is this force of tension here in red, this guy there, is going to help us. And what's interesting is, because it's the same rope and because it has the same force of tension, we end up with subtracting the force of tension and also adding the force of tension. Okay? A little bit confusing, but that's what we end up doing. The next components that we have here is we have the applied force working against us. Applied force, not the gravitational force. And we have the force of friction working against us as well. And all of that is going to equal our mass times our acceleration. I'll scroll to the right so you can actually see what I'm writing. Okay, all of that. So Fg minus Ft plus Ft minus Fa minus Ff is equal to Ma is what our final solution is going to be. So I'm going to simplify this down a little bit and also write it all in the same color. So Fg, this all cancels out. So we don't need to write that again. Minus the applied force minus the force of friction is equal to the mass times the acceleration. Now the mass for us is both of the two masses, the 72 and the 75 kilogram times acceleration. Now, when we look at this equation, we know most things, right? We already know what Fg is. We solved for that down here. We already know what Fa is. We solved for that down here. We know what the two masses are. We don't know what the acceleration is. We still need to figure out what this force of friction is. So that's going to be the next thing that we solve down here. We're going to figure out this force of friction. Now, the formula for force of friction is mu times F of n. We don't know F of n yet. We need to figure out what F of n is. Now, F of n works straight up in this direction here. So what we know then is that F of n is this side. Ooh, hello. This side of the triangle. It's the cos, because it's adjacent to 30, side of this triangle here. So we're going to do the exact same thing as we did right here with the applied force. We're just now using cos. So F of n is equal to mg cos, and I believe I gave us a 30-degree angle, right? 30 degrees. So this is then mass of 75, gravity is 9.81, cos 30. Okay, mass is 75, 9.81, cos 30. So 75 times 9.81, cos of 30, gives us a normal force of 637.18 newtons. Okay, so that's our normal force. Now that we have the normal force, now we can actually figure out the force of friction. So force of friction is equal to mu F of n. Force of friction is equal to 0.15, which I believe is our coefficient. 0.20, sorry. 0.20. And we're going to multiply that by 637.18. So our force of friction then is equal to 0.2 times 637.18 And we end up getting 127.436 newtons for our force of friction. All right, so all of this down here was all just set up so that we could eventually come back to this equation. We now know the last part of this equation. We know this force of friction, okay? So now we're at the point where we can actually go through and solve for our acceleration. So now that we know our force of gravity is 706.32, we know our applied force was 367.88, so minus 367.88, and we know our force of friction was 127.436 is equal to both of the masses. And why don't we actually just simplify that? So it's not equal to 150, it's equal to 147 times A. Simplifying what's on the left, 706.32 minus 367.88 minus 127.436. You end up getting an answer of, missed a number in my calculator. Ooh, hello. Sorry. 706.32 minus 367.88 minus 127.436. You get 211.004 is equal to 147 times A. So we're going to divide both sides by 147. And when you do, you get an acceleration of 1.435 meters per second squared is equal to A. So that's the first part of our answer. So again, we began this question with this idea. We wanted to use E is equal to MA. E of F is equal to MA. And what we said was we know parts of this question, but we didn't know everything we needed to. This was the formula that we had. We had FG from this blue part here, minus the force of tension plus the force of tension, minus F of A, minus F of F is equal to mass times acceleration. And so what we did is we went through and we solved F of A by solving for the bottom part of this triangle here. We solved for F of G over here, and then we solved for the normal force, which was this guy here. And then we're able to solve for the force of friction by going mu F of N. And so we figured out all of those components. We added our two masses up, and we were able to solve for our acceleration here. Now, the last part of the question is that we need to solve for the force of tension. The easiest way to solve for the force of tension is to basically ignore everything that we have done over on this part here, except for the acceleration. So what we're going to do is we're going to focus in on that blue block over on the right, the 72 kilogram one, where we have the force of gravity and we have the force of tension. And what we're going to do is rewrite our equation. Sum of all forces is equal to mass times acceleration. And now this time, we know our mass is 72, and we know our acceleration is 1.435. The reason I'm writing FG minus FT is because we know that ultimately this block is going to end up going in this direction here. So we know that FG is going to be bigger than FT. We've already solved for FG. It's 706.32. We don't know what FT is. And then 72 times 1.435 gives us 103.32, like so. A little bit of formula manipulation here. And what we get is that the force of tension is equal to 603 newtons. And that is our final answer for this entire question. Okay, so again, whenever you get these questions, first thing you need to do is figure out what direction is it going. Is it going from left to right? Is it going from right to left? We do that by comparing this FG with this FA. Whatever force is bigger wins. That'll be the direction that it pulls the overall shape. And then from there, you can put your force of friction either on this side or this side again, depending. Because we're going to the right, our force of friction goes to the left. It always goes in the opposite direction. And then we went through and solved. So, hope that was helpful for you. That is our solve of a ramp with a pulley and a block. I hope you enjoyed.